Hello students, today we are going to discuss our next chapter, that is problem solving. To solve any problem with the help of computer, what we have to do? We have to give instructions to the computer. Means before we wanted to get it solved with the help of computer, before that we have to solve the problem logically. Means what will be the step to solve this particular problem? And that instruction, means that step-by-step instruction, is known as algorithm for the computers. For every problem solving, we are to give the instructions. We have to give the instruction to the computer so that the computer will follow that instructions to solve your particular problem. So just we will discuss what is algorithm and how to create this, whatever our syllabus permits. So introduction to problem solving and programming. To solve any problem or to get any task done with the help of computer, what we need to give the step-by-step instructions to the computer. So each and everything you have to tell. So the process by which, means the steps are known as algorithms. And what is algorithm? Algorithm is a step-by-step method for solving any problem. This is the definition in your book. And what is program? Program is an algorithm that has been coded into something that can be run by a machine. Means whatever you have written in an algorithm, means whatever the steps you have written, whatever the instructions you have written, if you will give that instruction to the computer, you require one programming language. With the help of that programming language, you can write the program, and that programming language and that programming code, that source code, will be further converted into the machine code so that machine can understand. Okay, so what is the program? Before this problem solving, before this chapter, we used to discuss that program is a collection of instructions. Okay, collection of instructions. Here in the terms of algorithm, program is algorithm that has been coded into something that can be run by a machine. What is problem solving techniques? Let us discuss this. So in computers, means whenever you wish to write the algorithm, we need some steps, we need some flowchart that will help us to know where our program flow is going. Means what is the flow of our program, where the control is going. And this flowchart is there to help you in very surprising way to write the steps, to write the algorithm. How we will write the flowcharts, just we will see. But before that, let us discuss that what is flowchart. Flowchart is a graphical representation of the problem solving process. Graphical representation means whatever the instruction, whatever the steps we wanted to write, that must be graphically represented. You know, a picture is more than 1,000 words. A picture depicts more than 1,000 words. That's why the graphical representation is very, very important for anything, whatever we wanted to do. So in case of flowcharts, this is also very important. And with the help of this graphical representation, we can easily recognize what steps we have taken and what is the purpose of that step. Okay, it gives a step-by-step procedure for solving a problem. Just see, and elements of a flowchart. There will be some elements also, because this is the flowchart and we are going to use this flowchart to write the algorithms, to write the steps, to write the instructions for the computer. So it will be containing some elements also. And various geometrical shape boxes represent the steps of the solution. It is very, very clear by this line that various geometrical shapes are used as an element of the flowchart, and every different shape have a different meaning, different process, different steps. Means for a particular step, for a particular category step, we have to use that particular geographical shape. Boxes are connected by directional arrows to show the flow of the solution. Here, see, boxes are connected by directional arrows to show the flow of the solution. Means from which step we are going to jump on which step. This is being depicted with, this is being illustrated with the help of directional arrows. See, what is the uses of flowchart? First of all, we will discuss all the parts and then we will come to see what is flowchart and how we can write and how we can design any algorithm with the help of the flowcharts. So it is used to specify the method of solving a problem and how that problem will be solved. Whatever the steps we have to take, that is written in the flowchart. And it is used to plan sequence of a computer program. Means the sequence of the steps which are important to solve that particular problem, that is also written with the help of this flowchart. And it is used to communicate idea, solution, etc. Means whatever the steps, whatever the idea you have to solve that problem, with the help of flowchart you can. And it is not important that whatever the flowchart you are going to write, whatever the algorithm you are going to write, that is 100% correct. So if you have to discuss with your colleagues, with your friends, so first of all you have to create your flowchart so that they can easily understand, yes, these are the steps which are going to help us for solving that particular problem. So you can share idea, and from that flowchart, from your flowchart, it might possible that everyone gets a better solution. Means when you are working in a team, so it is helpful to communicate your ideas, and it is quite possible that your algorithm might be selected. Means that must be correct also. So this is the importance. Means you can write the steps, you can write the sequence of the steps, what will be the sequence, and then also you can communicate the solution and ideas also. See, some geometrical shapes are here. These are the elements of our flowchart. So the flowchart symbol, it is ellipse, and ellipse geographical shape is this. What is the purpose of this particular geographical shape? Whenever you are going to write the flowchart, you can use it for the start symbol. Also you can use it for the stop. Okay, start and stop, all these steps can be denoted with the help of this ellipse. Parallelogram, use a parallelogram. This is used to give input and output. If you wanted to take input, you will use this. If you wanted to show any output, you will use this. Okay. And rectangle is there to show the processing, and the diamond box is there to show the decision making. It has two connecting edges, one is for yes, one is for no. Means if that decision is correct, then the step will be taken that is connected to the S, and if the decision is wrong, means the false, then the box connected to the no edge will be connected, will be followed. We will see with examples also. This is flowchart, means arrow. These multiple arrows are there. Any type of arrow you can use depending on the steps, depending on the sequence. So these flowchart steps connectors, and these are the flowchart step connectors. And then parallelogram. Just 1 second, this is not the parallelogram. This is connectors. This is flowchart connectors, and they are used to connect the multiple different parts of the flowchart. Suppose you are drawing your flowchart and that is running out of your paper. So to connect the chart on the second paper from first paper, this type of connectors are used. Okay. So now here is one flowchart. This flowchart is about, there is one problem. And what is the problem? Problem is that you have to go to a birthday party, and depending on the money, means depending on the pocket money, you will decide the gift, and after buying that gift you will go to the party. So suppose you are the candidate. So what, first of all we have to start. The ellipse symbol is there, then parallelogram is there to get the money, means receive the input, get money from your pocket, your wallet, or your parents, from wherever you want. And then if money is greater than or equals to 150, then you will buy book. This is buy, this is not but. So if the money is more than 150 rupees or equals to 150, then you will go for a book, and then you will go to the party and after entering the party your problem is solved. Means this algorithm is for to purchase a gift, means how you will decide which gift you have to purchase. So if the money is less than rupees 150, then you will go for the card, birthday card or whatever card. So first of all we started, the ellipse is there, then the arrow symbol is there to show the flow. From that start we are going on the input step. This parallelogram is used for the input, and then input, and after that input, and here go to the birthday party we can show as output also, and we can show it as a process also. Means if you wanted to show it as a process, then the rectangle symbol will use, and if you wanted to denote it as a process, then go to birthday party will be displayed in the parallelogram. So this is the flowchart, and in this maximum elements are used, only the circle connector is not used, that is used to connect the different parts of the flowchart from one page to another page. So here we can understand, and this picture is capable enough to illustrate the problem and the solution also. And very easily you can see if you are from the programming background or you are not from the programming background. In the same cases, in both the cases, you can understand what is the solution. Means you will start, then you will get money, means you will take the money from the sources, and then if is money greater than 150, yes, then buy the book, or no, then buy card. And after buying card or book, whatever you are purchasing, means whatever your pocket supports, then you will go to the party and then stop, problem solved. So this is the purpose of flowchart. Now the programming languages and language translators. You have written algorithms in your language. But computer doesn't understands our language, and this instruction is written for the computer. So we need some languages. That language will help us to write the program, and we require language translators. These translators will translate that program into the language which our machine understands. Means the programming languages for us, for humans, in that language we will write our programs, and the language translators are there. They will translate that programming language into the machine language. That language machine understands, means the language that computer speaks or understands. So what is language? First of all, language is a medium of communication, so we need a language to communicate with computers. Means in our real life also, if we wanted to communicate, we require one language. We use Hindi. What is Hindi? Hindi is also language. We use English. English is also language. In this video class, the medium of communication is English language. So to communicate with the computers also we require one language, and that language is the programming language. Computers can understand only machine language, so the language used to communicate with computers are known as the programming language. Not so, means this is another point. Languages used to communicate with computers are known as the programming languages. Because computers understands program is the collection of instructions. So instructions are required for the computers for the processing of the computer. So to give that instructions we require one program, and we require one language that supports us to write the program. So that language is known as the programming language. Then machine code. What is machine code? Computers can understand only the language, and means computers can understand only one language, and it is called machine language. It consists of series of zeros and one. 0 and 1 are known as the binary digits, and 1, 0 and 1. These are known as the binary numbers, binary digits. So machine code is written in the binary language only. Binary language and hexadecimal also. But hexadecimal is, means on a smaller part it is also converted in the binary. So we will talk about the binary only, and we will talk that this is not binary, this is not hexadecimal, this is not octal. This is just the machine language for the ease of our access. So machine code is, this is the example of the machine code. Instruction is written here, and that is your, whatever it is written we cannot understand. This is for the machines, so machine can understand it easily. And it is not easy for the human being to memorize all the codes, to memorize this instruction. And if you are to write this instruction, it is a little bit difficult how you can write. You have to memorize all these things. So that's why we require some another language that is user friendly, means that is for us, in which we need not to memorize all the things. We have to write the instruction step by step, and that will be converted later in the machine language, and that language means that code will be instructed or executed by the machine. So programming language, it is of two types. One is the low level language and another is high level language. What is low level and what is high level? Low level means that machine understands, means that is not easy for human. And high level language that supports natural language, means that supports English, and it gives the interface to the users to write the programming instruction in the English, and then it converts that instruction into the machine code for the machine. Means it works like the translator. But low level languages are mainly that supports maximum of the machine code only directly. And the example of low level language is assembly language, and the high level language is QBasics, which you will read in this syllabus. C language, C++, C#, .NET, Java. These are the high level programming languages. So assembly language. In assembly language, mnemonics were used. And what is the mnemonics? Mnemonics are the short form of the instructions. Means they are the codes that is used in short to depict, to illustrate one instruction. For example, LD is written there for load, ST is written for store, SUB written for subtract, ADD written for addition, MUL written for multiplication. So this type of codes are used in this language, and these codes are known as the mnemonics. Okay. And assembly language is low level programming language. Next, QBasic, which we have to study in our syllabus in next chapter also. So QBasic is a high level programming language, high level language. And in short, high level programming language is written as HLL. In HLL, we may write the instruction in natural language, means that is English. We can write the programming instruction in English, and that will be converted later on in machine code for the machine. So what is assembler? We discussed here assembly language. So assembly language, whenever you use assembly language, one assembler is used, and this assembler converts the code written in the assembly language to the machine code, to the machine language. Just see. It converts any assembly language program into machine code, and machine code is used for execution of the program. Because ultimately that instruction is for the computer, so that must be executed, and for the execution, to ensure the execution of that code, that must be converted into the machine language, that language which our computer speaks and which our computers understands. So here is one picture from your book, that is the mnemonics or the language. Mnemonics languages are the source code, and then it go to the assembler, and assembler then converts it into the machine code, and then machine executes that code. Now, high level language translator, what is the term here? Because I discussed before this slide that high level language gives us interface to write the program in our natural language, and that language is not of any use for the computer, means that is not understandable by our computer. So how that instruction is executed? It means some translation is being there. There is someone who is translating the code, means who is translating the programming code written in English to the machine language. And in your book, one example is there that suppose you wanted to go America, and you do not know English. No, do not go America. You wanted to go to the Japan, and you do not know the Japanese. And suppose you have to go there and you have to travel. How you will communicate there? Either you have to learn the Japanese, or one thing you can do easily, means learning Japanese is not easy, means if it is not difficult also. It is not much difficult, but it is not quite easy also. So what you will do? You will take one translator, you will take one guide, you will take one translator on hire, means you will hire them. They will receive your instructions, means they will receive your masses, whatever you will say in Hindi, they will receive that and they will convert them into Japanese, and then they will forward to the next, means forward to whom you wanted to communicate. Suppose you wanted to communicate a professor in the Japan. So what he will do? The translator will translate your saying, whatever you say, in the Japanese, and then whatever that Japanese professor will say, that will be converted back in your language which you understand. Means if you understand Hindi, if you understand English, it means in this case we are assuming that that professor doesn't understand any other language, he understands only Japanese and you understand only Hindi or English, whatever. So the translator will do, translator is there, he speaks both the languages, means your language also and the language of that Japanese professor also. So in the same way the high level programming languages are working. They have their translators also, and that translators are there to translate the code written in English to the machine language. So first translator, that is interpreter, and it is a language processor. It is also known as the processor that translates the single line into machine code at a time. And here is one example. You have written 4 lines of a code of 4 lines. So what is being, means what exactly is being, the first line is being executed, that is being fetched. First line is that print hello, and it is being translated into the machine code, and then it is executed, means hello is printed on your output screen. Then again control goes to the programming lines, and then second line will be fetched, and then that will be processed, that will be converted into the machine code, and then that will be executed. Then again it will go for the third line, then that will be fetched, then that will be translated into the machine code. Then after execution again it will go for the next line, that will be fetched, and again that will be executed, means that will be translated into the machine code, and after the execution the program finished, means program So what is compiler? This is also a type of translator, high level language translator. So it is also a language processor that translates the complete program as a whole in one go into machine code. Here all the codes are executed, means processed at once, and after processing our compiler gives us error, if there is any error, with line number. So how it is possible? See, you have written a 4-line code. This code is known as the source code. Whatever the code you are writing for the program, that is known as the source code also, and that is going to the compiler. All the lines are being taken all together, and then compiler converts all at once in object code. This object code is also your machine code. Here we have written that program written in high level language is called source code, and the program translated into machine code is called object code. Okay, so all the programs are converted all together into the object code or the machine code. Here is one short difference chart: compiler versus interpreter. So compiler takes entire program as input, but interpreter takes single instruction as input. Intermediate object code is generated. Okay, and source code is converted into object code, and then that object code is used by the machine to execute the codes whenever you wanted to execute the instructions. And in interpreter, no intermediate code is generated, means every time that line is converted into the machine code directly. Memory requirement is high for the compiler, because once you have written your source code, that will be converted into the object code, and that object code will also be saved to your memory. That's why memory requirement is high for the compilers. And for interpreter memory requirement is very less, means as compared to the compiler, because it doesn't convert that machine source code into the intermediate object code, and that is directly converted into the machine code so that machines can understand. And then program need not be compiled every time. When you use compiler, and at the time of compiling, that code is converted to the object code, means you need not to compile that code every time. Once that code is compiled, object code is generated, so you can use that object code. But in interpreter there is no object code, so every time that program needs to be converted into the machine code. All errors are displayed after entire program is checked, means in compiler all errors are checked, and they are after that calculation, means after that processing, that errors are displayed, but in interpreter errors are displayed for every interpreted instruction. Suppose you have a program of 10 numbers, 10 lines, and there is any error on the line number 5, then program will stop the execution after line number 4, because on the line number 5 there is one error, so it will show the error and it will wait for the correction. If you will correct, then that will be processed, otherwise the program will terminate on the line number 5. Execution will terminate. Okay, and example of that compiler based languages are C compiler. C language uses compiler, C++ uses compiler, C# uses compiler, Java language uses compiler. Okay, and interpreter, example of interpreter has the QBasic, Python. They are the interpreter based languages. And this is the end of this chapter. Okay, and on next class we will discuss the next chapter. Okay, bye bye.